Hey, what's up, coders? Welcome back to the channel Code with AKJ. Today is day 23 of solving Geeks for Geeks problem of the day. Today's question is nth natural number. It's a fascinating problem that seems simple at first but offers a lot of depth. So the question says here is given a positive integer n, you have to find nth natural number after removing all the numbers containing the digit 9. The task is to find the nth natural number after removing all the numbers containing the digit 9. So the brute force approach here would be to consider a variable counter here, and we need to iterate over the value till it reaches n, and we'll check each and every digit. If it contains n, we'll skip it, and if it does not contain, we'll increment the counter. So I'll explain through the diagram here. So I've taken the value n here 8. So I've taken the current number which will run from 1 to n, and we'll also take a variable count which will be initially 0. So the brute force approach here would be to run a loop where count variable starts from 1 and it reaches till n. If count value or the current number value contains n, we'll skip it, or else we'll increment the count variable. So if the current variable becomes n, we'll break that loop and we'll return the count variable. So here is the dry run for this value n. So here we'll run the value from 1 and we'll check whether it contains 9 or not. So here it's not 9, so we'll increment the count variable 1 from 0. We'll loop this current number till n. So here 2 does not contain n, 3 no, 4 no, until 8. So here since count value becomes 8 and it equals to n, we'll break from the condition and we'll return the count variable which is 8 here. So another example here for n value 9, current value starts from 1 to n and count variable will be 0 initially. So we'll check here if it contains 9 digit or not. So at one point when the current number will be 9, as we can see that it contains 9, so we'll skip that condition and the count variable will remain 8. So after completing 9, we'll move to 10. It does not contain 9, so we'll increment the count variable from 8 to 9, and since count value becomes equal to 9, so we'll break from the loop and we'll return the count value which is 9 here. So in this way I'll tackle this problem using brute force approach. So let's code this approach and see whether it gets submitted. So this is the code for the brute force approach we have discussed through examples, and here I've taken two variables, count variable and current number. I've used a while loop condition where it runs until or unless the count value becomes n. I'll increment the current number for every time the loop runs, and I'll check whether this current number contains a digit 9 or not. If it does not contain, we'll increment the count, and the function goes here. We'll check each and every digit of the number. If it contains digit 9, we'll return true, or else we'll return false. So here time complexity would be O of n, and space complexity would be O of 1. So let's compile this and check whether it gets submitted or not. It's working now. Let's submit. Let's see if it gets accepted or not. Okay, it gives time limit exceeded. So the question requires us to use O of log n time complexity, as this code is O of n time complexity. So we need to optimize this approach. Now brute force works fine for small values of n, but imagine we are asked with the 1000th value. So it will generally take ages to compute. So let's optimize this solution using a trick involving base 9 concept. So I'll explain through this. In this optimal approach, the key idea is to convert the number n to its base 9 equivalent. So why base 9? Well, because base 9 avoids the digit 9 entirely in its calculation. So since it uses digits only from 0 to 8, so by treating our number as a base 9 number, we skip all the numbers that contains digit 9. So the steps would be to convert the number n into base 9, and the value which we'll get after converting into base 9 would be our returning value. So for example here, if the number we encounter contains digit 9, for example 19 here, the baseline representation of 19 would be 21, so it automatically skips this particular number and moves on to the next number. So in the same way, we'll use this particular logic here in our code and we'll try to optimize it. As we are converting a number into different base value, the complexity here would be in the form of logarithmic. So it will be as same as the problem statement requires. So the time complexity here would be O of log n, and the space complexity would be same as the brute force approach, which would be O of 1. So let's try to code this approach and we'll see whether it gets accepted or not. So the optimized code for the problem statement would be like this. So we'll take this values, result variable and place value, which will generally goes from 1 to units place, 10th place and 100th place. So we'll multiply it with 10. So we'll consider it as a base value here and we'll run a loop till n becomes 0. We'll convert this value using this reminder and we'll multiply it with place value and we'll add this value to the result variable and we'll divide the particular number till 9 and we'll increment the base value by multiplying it with 10. So in this way we'll convert this number into base 9 equivalent and finally we'll return the result variable from the main function. Let's compile and run and check whether it gets accepted or not. It's working, so let's submit. As you can see, this way of solving our problem gets accepted successfully, and here the calculation takes a logarithmic way, so the time complexity would be O of log n and space complexity would be O of 1. So there you have it. We have explored both brute force and an optimized solution for finding the nth natural number after removing all the numbers containing the digit 9. So while the brute force approach works for small inputs, converting that number to base 9 gives us a far more efficient solution. So if you found this video helpful, make sure to hit the like button and subscribe for more coding tutorials. Drop any questions or thoughts in the comments and I'll catch you in the next video. Thank you.